Hello, everybody, and welcome to our webinar this morning. This is part of our webinar series here at Team Rehab Physical Therapy. Very excited today to have Matthew Hart from Soter Analytics, the CEO and founder of Soter Analytics. The company is based in London, England. However, they are continuously growing and have offices now in Australia and recently have come to the States in Chicago as well. So right down the street from me. My name is Mike Steinborn. I should probably introduce myself first. I am the Injury Prevention and Workers' Compensation Manager here at Team Rehabilitation. Met Matt a couple of years ago at a trade show in San Antonio, saw the technology that he was working on. He talked about human engineering and reliability for humans, and I had no idea what that meant at the time. But in the past couple of years, I've gotten to know him more and talk to him more about it, and it is a fascinating concept. And he and his team are doing some, fantastic things in the field. So we're excited to have him today. And with that, I will say, Matt, go take it away.
Awesome. Thanks, Mike. Appreciate it. Welcome, everyone. So my name's Matthew Hart. As Mike said, I'm the founder of Soter Analytics. Today I'm going to be talking to you about reliability for humans. Let me just get my slide working. Okay, so this is the agenda that we're doing today. So I'll give you a bit of my background. I'll talk about what is reliability engineering. I'll talk about a couple of concepts of reliability engineering and especially like how you can apply these concepts within your job and within the safety profession. I'm going to be talking a lot about how we use these techniques for machines. Part of my thinking is that people are very similar to machines. Another part of my thinking is that people are very different to machines. So point 4 is actually talking about the differences and where we can't just treat a person like a machine. And then I'll end this webinar with a bit of a description of what Soter Analytics is doing, how we're applying these reliability engineering techniques for humans and the products that we're making and how they work. So let's get into it. This is what I looked like back in 2010. So I had just finished my mechanical engineering degree. I have a bachelor degree in this. In 2010, I got a job for BHP Mining, which is the biggest mining company in the world. And I was working in the Australian outback. So in the middle of nowhere, I would fly up for 5 weeks, sometimes 5 days, sometimes 2 weeks at a time. I would work that entire time and then I would take an airplane and fly back to Perth, which is where I was living at the time, Perth in Australia. So I started in 2010. In 2012, while working, I was studying reliability engineering. So I have a master's degree in that. I learned some really interesting things and started applying that to my role. And then I got an MBA in 2017. So between 2010 and 2016, I was working as a reliability engineer and a productivity specialist for BHP Mining. I did that obviously for 6 years and then I stopped and I started Soter Analytics because I thought I had learned a lot of interesting techniques that I could apply to keeping people safe as well. So I actually started a whole business based on what I had learned and how I could apply this. Okay, so we better start by explaining what is reliability engineering. Reliability, it's the ability for a system or a component to function for a specific period of time to a functional level. So what we are doing as reliability engineers is we're really trying to make sure that whatever we're building or whatever we're designing or whatever we're maintaining is working at the level that is required for the productivity output that we require. It's not breaking down on us unexpectedly, and we're getting a consistent level of performance. If we look at reliability engineering for airplanes, which is one of the most important industries that uses that relies on reliability, when they're building an airplane, they test extensively. So they're making sure they're building the airplane with the right materials. They test that these materials are going to last for as long as they believe they're going to last. So when they're designing a new airplane, let's look at the wings specifically, they're actually testing these wings for a full life cycle of the airplane. So if an airplane has a design life of 30 years, they don't test it for 30 years, obviously, because that would be very slow. but they're testing it in a way that replicates the performance over a 30-year life cycle. And it's not just testing one set of wings. They would have dozens or maybe even hundreds of wings that they run with different tests to make sure that the materials are going to survive for as long as they need. Then they do frequent servicing and testing. So when the airplane is actually built, it's why every 600 hours an airplane engine is serviced. So it's not waiting for the engine to break and then service it, because obviously that's not ideal, especially in an airplane. So every 600 hours, they stop the airplane, they service the engine, they make sure that there's no problems, they might replace certain components, and then the engine is ready to go back to work. It's also why, for example, a 747 airplane, it has to be retired after 35,000 flights. So when it comes to reliability engineering, sometimes we're not willing to take any chances. When it hits 35,000 flights, we know that the reliability is going to start dropping. I'll explain why in a couple of my next slides. But we know after 35,000 flights, we stop that airplane. It's done. It will never fly again. So these are three basic examples of reliability engineering as it applies to airplanes. Now, you can see there's a lot of testing, there's a lot of technology. I'm going to talk about a lot of sensors as well. How we protect our people is actually 15 years behind how we protect our machines. So companies are putting a lot of effort, a lot of money, and doing a lot of testing, a lot of resources into making sure that our machines don't break, which is a very important part of, as a business, what we're delivering, whatever product or service we're delivering. But when it comes to people, the techniques that we use, I would say, are 15 years behind. I'm going to explain why. I'm going to explain what these techniques are, or at least 4 of them, and then how we can use reliability engineering techniques to actually apply it to people and catch up to how we protect our machines. So concept 1 is the bathtub curve. So this is one of the very first things that I learned in my master's degree as a reliability engineer. When you look at a certain component or you look at a machine, there's actually 2 main times that that machine is going to fail. It's going to fail right at the start. So maybe it wasn't built in the right way, maybe it wasn't installed in the right way, maybe it's just the wrong tool for the job or the wrong machine for the job. So startup commissioning is actually a big part of when a machine is going to fail. Sometimes if it's going to fail straight away. The second time it's going to fail is when it reaches the end of its useful life. So this is called normal wear out. So we've designed something to last for 35 years, let's say. Once you get to 35 years, you're going to see that it's going to start failing. Sometimes you can manage this failure. Sometimes you can do maintenance to reduce the failure rate. Sometimes you can measure this failure rate and actually proactively manage it, so you don't have to stop the machine from working, you don't have to retire it. And other times, like the airplane that I explained, you just have to retire the machine. It doesn't have a useful life anymore, it's too high risk, we need to replace it with a new one. This line here is called a wear out curve. Sometimes the wear out curve can be quite steep, like this one is, so it's going to fail quickly. Sometimes this wear out curve can start all the way down here and can be quite gradual. When wear out curves are quite gradual, it's something that we are able to measure over a period of time, and we're then able to make a prediction that, okay, something's going wrong with this piece of equipment, let's do some maintenance or let's replace it. Let's not wait for the failure. We're measuring that something's going wrong. Harder to do when it's more steep. It'll be just a sudden failure. Okay, so in real life, what is an example of this bathtub curve? The best one I could think of was when you're buying a car. We've all heard of a lemon. If you're buying a lemon, you're just stuck with a car that just keeps breaking down. You buy a new car, you know, it just doesn't work. And in some countries, there's even things called lemon laws for cars. So that if you buy a car that just keeps breaking down early on in its life, you can actually replace it for a new one, no questions asked. The second time a car fails is at the end of its life. You know, the car becomes old and starts rusting, or components start breaking, and after a while, just so many things start breaking with that car that you say, okay, this car is finished, we've had a good run, it's time for a new car. So this is a real life example of the bathtub curve. Usually, especially cars these days, when you're in the middle stage of its useful life, you don't have many problems. You might do regular servicing, you might change the oil, you might change a starter motor or a spark plug here or there. But for the most part, this car just works like normal. And then all of a sudden it hits a point where everything starts breaking. When we look at bathtub curves for humans or for workers, we see something very similar happening. So when are you going to see injuries with your workforce, especially injuries of the physical nature? So when your body starts breaking down, it might be a back injury, it might be some other sort of joint injury, it might be your knees. Very often we see new workers are failing. This is because they're not used to the job, they're not work hardened, they don't have the experience required. So you usually see a big injury spike with your new workers. Then the ones who get through that period start to get work hardened, start to get experienced. They'll have a normal career, I would say. Very often nothing happens to them for years, sometimes decades. And then they start aging. And we see that wear out starting to happen again. Their back suddenly hurts in ways that it's never hurt before. Or they might start getting a pain in the shoulder. Or they might start getting an RSI in their wrist. This is the wear out curve. Sometimes this happens very quickly. Sometimes, again, this happens over a very long period of time. What's happening to this worker is their capacity is getting less. So their body is just becoming weaker. And the job that they're doing might not be getting easier. It might be exactly the same requirements, the physical requirements of a job. Their body is getting weaker. These two will intersect. You've got a problem. So this is one of the reliability concepts that really applies to humans. There's a couple of strategies that we can put in place for these new workers. We can do functional job testing. So we could test the physical requirements of a job, and you can do post-offer testing as well. So you can measure who's going for the job. And there's many companies out there that are expertise in this, and you can use that to measure, does this person have a realistic chance of being job hardened and surviving the physical requirements of the role? The second thing you can do, which I really believe in, is you can do new starter training. So high quality new starter training to actually teach them the techniques early on that is going to give them the best chance of being work hardened and survive the physical requirements of the role. For aging workforces, or aging workers specifically, early intervention is really good. So this is where we start measuring that wear out curve that I drew for you before. So if you start getting the niggle here or there, early intervention is the key, because very often you can rescue it. You can actually help that person not wearing out more and more and getting to a point where something breaks and then they have a recordable injury. You can fight the wear out curve with good maintenance. You can do it in machines and you can do it with people. The second strategy that is quite obvious, I would say, and quite commonly used, is you actually transition the experience of that person into new roles. So they've got a lot of experience in the business. You might put them in a supervisor role or a managerial role, or in a role in the business that is less physically have less physical requirements. So moving on to the technique number 2. This is a personal favorite of mine. I live a lot of my life by this, actually, the Pareto rule. So only 20% of what you do makes 80% of the benefit. Or to put it another way, 80% of the effects comes from 20% of the causes. Back to when I was on this mine site, I was working on a strategy for excavators. So this is a Liebherr R996 digger. This digs iron ore and puts it on trucks. We had I think we had 8 of these on site. And my job as a reliability engineer was to analyze where we were losing time and money with these machines. And money mostly comes from breakdowns. So when was this machine breaking in a fashion that we weren't planning for, we weren't predicting? So these are called unplanned breakdowns. So I analyzed a whole year of data, 2014's worth of data. We found that it had a boom crack. So that's a crack in this section here, if you guys can see. So we had a boom crack that caused almost 2 weeks of downtime, I think it was. So obviously this is super, super expensive. I think the failure cost about $10 million in the end. So a lot of lost productivity. We had 45 starter motor failures. So starter motors are something that helps the main engine start and operate. We had 54 of these over a year, and each one on average was 1.2 hours each. 1.2 hours is not a big number. We had 6 shifts, 6 maintenance shifts on the site. So, and we had about, I don't know, 20 fitters or 20 maintenance people on each shift. So if you're not looking at the data and you're just talking to people, we weren't able to see that this was a big problem, because 1.2 hours every now and then is not a big deal spread across all the different shifts. But when you add up the 54, 65 hours over a year is a huge number. So it was happening frequently. Everything else that happened to this machine cost 100 hours. So there was about 30 or 40 other failure modes. So you add them all up, you got 100 hours. So if you just look at these two things, you actually get 80% of the effects just from 2 failures. And you don't have to worry about the 40 other ones. So a boom crack, that was something structural with building the machine that was quite difficult for us to put something in place to help manage that or help reduce that. The 54 starter motor failures, I actually went with a maintenance crew to figure out what was happening. What was happening was it was so hot that you were shutting down the machine and it was just too hot in the engine bay for the starter motor to actually start up again. The resistance was too high. How hot was it? So we went in there. It was 65 degrees Celsius, which is 150 degrees Fahrenheit. So it was super hot. We actually had to go in there. We had to reach over hot equipment to pull out this starter motor, which weighed, it was heavy. And we had to replace it with a new one. When the safety guys heard about that, their solution was, okay, we need a lighter starter motor, which is the wrong solution, by the way, and I'll give a strategy in a second about why they came to the wrong cause of the failure. So they said put a lighter one in so that when you're leaning and you're taking it out, it's not as physically demanding on the maintenance person. What we actually had to do is put a much heavier starter motor in, because we needed something that had a higher capacity to actually start the engine and not fail. So we replaced all the starter motors, we removed this failure mode, and we saved 65 hours of downtime every year, which is pretty cool. That equates to millions of dollars of savings. So, Pareto rule for humans, your people are breaking down as well. So, got to be a little bit careful here. In my last point, you'll see that when it comes to humans, there's a severity. Back injuries, when you look at them, they're happening fairly frequently in a lot of industries. They're costing a lot of money. As a combination, they're really expensive. Falls from heights might never happen. Well, fingers crossed they never happen. They might happen once, but when they happen, they kill people. So you've got to be really careful when analyzing where your risk is coming from your workforce to make sure that you're focused on the severity as well. But it can help you not focus on things that don't really matter. So you might have an injury type that's happening frequently but doesn't really cost a lot to the company or doesn't really hurt the person. You might hear a lot of noise from the people because it is happening frequently. And no matter what, we don't like frequent injuries, of course. But there might be something hidden in the data that you can see actually causes a lot more pain for the people or costs the company a lot more money. So analyze your data in a way to actually see where the cost or where the severity is coming from. Focus on the 20% that really matters, because that's where you can make the biggest impact. And the rest, the 80% of other stuff that happens might just be noise or might not be the things that you should be focusing on. So this is how you can use the Pareto rule to focus on the injury types in your workforce that really matter. It's just an example. You guys have your own data sets. You analyze your own data. If you need help on analyzing data, this is something my team does really well. So we'll do that even for free. Like if you want us to coach you on how a data set should be analyzed, just let me know. So we go into principle number 3. This is called root cause analysis. So when an incident happens, I'm sure you guys out there are very often doing an analysis on why that injury happened or why that incident or accident happened. Hopefully you're using some sort of root cause analysis technique. Root cause analysis itself especially helps when there are multiple failures that occur that contribute to an incident. So I've got an example of this. Probably many of you remember the Apollo 1 fire. So they were on the ground, they were doing some testing, they had what seemed like one failure, and that caused a fire, and unfortunately the astronauts in the capsule perished. But when they did their root cause analysis, they found multiple things that went wrong. So if we look here at the failure modes on the right-hand side, what NASA found was if one of these things didn't happen, or one of these things were solved, the actual fatality wouldn't have happened. So if they could have got the hatch open very quickly, they would have got out. They wouldn't have, unfortunately, been stuck and perished in the fire. The spark was caused by inadequate insulation. There was a lot of combustible materials in the cabin. They used pure oxygen at the time, so this was just the perfect environment for an explosion to occur. And there was no rescue people on site as well. So when this incident happened, there was nothing anyone could do. They just unfortunately had to watch it happen. So root cause analysis, another way to think of this is like a Swiss cheese, you know, the cheese with holes, and there's different holes. And when these holes line up in a certain way, that's when an incident happens. If one of these 5 things had not happened on the right-hand side, the incident wouldn't have happened. So when you get to complex failures or complex injuries or accidents, don't just look at one failure mode. Many things usually go wrong. Look at them all and put in controls for all, because next time when something happens or has the potential to happen, hopefully one thing doesn't happen and then the incident doesn't happen and the big problem doesn't occur. Then you get into more simple incident investigation. So one of the things I really like to use is something called the 5 whys. This is a technique to make sure that you actually get to the correct root cause. And the theory here is don't just ask why something happened once, ask 5 times. So ask why, then you get an answer, and then ask why did that happen? And then you get an answer, then ask why did that happen? And what people have found is usually if you ask this why 5 times, you actually get to the root cause. I'll give you guys an example of that. So we got a hypothetical situation here. A worker slips and falls and suffers an injury. So the investigator goes out there and he or she says, why did this happen? Well, there was a puddle of oil on the floor. So to me, the answer is quite simple, right? Like, there's a puddle of oil. We don't like puddles of oil. Let's hire a cleaner, or let's tell the cleaner to clean more frequently or be more dedicated, or hire more cleaners. But let's make sure that we're always cleaning the floor so that if there is oil, we don't have someone slipping on it. But if we look at, okay, there was a puddle of oil on the floor. Why was there a puddle of oil on the floor? Well, oil spilt from a compressor. There's a compressor sitting there, it's spilling oil. Okay, why is oil spilling from a compressor? Well, there's an oil leak on the compressor and nobody detected it. Okay, interesting. Why did nobody detect it? Because the compressor was not inspected on a regular basis and repaired if there was a problem. Why was it not inspected regularly? It's not in the maintenance system. I know I'm blocking the last words, but the fifth why and the root cause of this problem is the compressor is not in the maintenance system. So remember, if we had just stopped at the first why, we're hiring a new cleaner or we're telling a cleaner to clean more regularly. But what our real problem is we've got equipment that's not in our maintenance system. Why not? You know, if we fix that, we're not going to have puddles of oil on the floor. This is how you can use the 5 whys to actually come to the true root cause of something. Okay, principle number 4, and it's the last principle that I talk about. It's predictive analytics. So even in my career, you know, it's not very long. I'm only 30 years old. I've seen a big shift in reliability engineering from looking at purely historical data to actually building predictive models and using predictive analytics. So predictive analytics, if we're looking at a definition of this, it's combining historical data using advanced analytical techniques to try to predict the future outcome. So if we look at airplanes, if we just use historical analysis, we know that if you're testing a 747, that the fuselage is going to become too weak after 35,000 pressurization cycles, so 35,000 flights. And that's why we have to retire the aircraft. That's historical analysis. We've done the testing. We know that 35,000 is the max number. But as someone who used to, at least, take a lot of flights, what happens before 35,000 pressurization cycles? I want to know that something is happening in between, so that if something is wrong with this airplane, it's not going to break up in the air, and obviously that's a very bad thing to happen. So the second reliability technique that is used in predictive analytics is condition monitoring. So condition monitoring is we take the aircraft out of cycle, out of production, and we test it. So what we do specifically for the fuselage in an airplane is we test it for cracks. So this guy is using a special sort of sensor. It's kind of like what they use to test, it's sort of like an X-ray. And he's actually testing to see if there's cracks being built. So they take aircrafts out of service probably once a month, let's say. They'll fully test it. They'll scan in all the known areas and sometimes in the unknown areas, and they'll be looking for little cracks. And if they detect these cracks, okay, we've got a problem. We actually have to repair this aircraft. We're not waiting for 35,000 flights. We're actually doing something now, because this aircraft, if we don't do something, isn't going to last the 35,000. So, okay, let's say we've got a 4-week cycle where we're taking the airplane out and we're doing this condition monitoring. But what happens between the 4 weeks? And this is where predictive analytics is really getting to these days with equipment, is we're putting actual sensors on the machine to measure in real time. So something that they've just started working on for the last 3 years is actually measuring micro cracks in real time. So newer aircraft now are being fitted with sensors in the fuselage or in known areas around the windows or near the wings to actually measure if micro cracks are happening in real time. So we don't need to wait for the 4 weeks anymore. Of course, we're going to check a lot in the 4 weeks. But in the meantime, we're going to get data coming to us as reliability engineers. We're going to see that micro cracks potentially are starting to form, so that when we stop that machine in the 4-week cycle, we're not going to test and then realize we've got a problem. We actually know already that a problem is forming, and we're actually going to repair the problem. So this is how reliability engineers are predictively telling that we're about to have problems with our machines, and they're putting in really good repair strategies or maintenance strategies. So how can we apply this to humans? Well, we can do the historical analysis. I think we're doing that quite well within safety teams at the moment. You do have to be disciplined. You have to make sure you're analyzing the right data set. But a historical look at what's happening to your people is a pretty good predictor of what's going to happen to them in the future. So this is just all about data. You need data sets to make this happen. And the bigger you can make your data sets and the more granular you can make your data sets, the more chance you're going to actually have of creating a model that is going to be predictive. So using data sets that are measuring injuries only is okay, but injuries don't happen that frequently, touch wood. And in some industries, they happen more frequently than in others, but it's quite a small data set. It's not happening that frequently. What is happening more frequently is when people are reporting pain, for example. So 10 people might report pain or report that they're starting to have a problem. Only one person has an injury. So suddenly your data set gets 10 times bigger. Even better than that is measuring events that cause pain or cause injury. So we don't even have to wait for the pain to happen if we can measure things that are causing that even before it happens. We don't have to measure, if we take it back to an airplane, we don't have to measure that the wing falls off because of a crack. That's measuring injuries. That's not good enough for an aeroplane. We don't have to wait for a big crack to develop or for us to take it out for 4 weeks to measure it, to measure if these cracks are happening. What we want to know is when these cracks start happening. The more we can measure that, the more chance we have of making sure that this machine, or in this case, this person, is ready to do their job or is fit to do their job without breaking down. Engineers are really trained in this. We do a lot of mathematical stuff in our education. We're used to working with big data sets. What I found is, like, when it comes to people working in safety, they might not have these expertise, but I would really encourage everyone to learn. There's plenty of free courses. There's heaps of stuff on YouTube for free. Now universities in the US are offering data analytics courses for free as well, or quite low cost. So the more you can get comfortable in analyzing data sets, the better I think you'll be at predicting future injuries. The second thing you can do is work with experts. So whether it's consultants, whether it's occupational health providers or specialists, whether it's the people in my company at Soter, we can help you as well on this. Predictive models is really specialist. We have data scientists. We have 4 data scientists working on our team, for example. So I'm going to explain what we do in more detail in a second, but we really analyze data sets. So if you guys have data sets and you're like, okay, what do I do with this data? And you're like tearing your hair out, I don't really know what to do. Have a chat to us. We'll help you out. Condition monitoring is another thing you can do for humans, but scanning all workers on a periodic basis is probably a bit of a stretch. So you can imagine bringing someone in and scanning their body or saying, how do you feel? How does this part feel? That's not really going to come across very well. But there's something else you can do. And it's all about just encouraging early reporting. The earlier you can understand that a person has a problem, the better chance you have of doing something to stop the pain from developing, from the recordable injury from happening. It's all about early reporting. I really encourage that. That's what we do with the machines. The quicker we can understand that something is starting to fail, the better we can put in a strategy to stop that from happening. Workforces don't like to early report. It's not comfortable, especially, people just don't like early reporting. So there's something that, as a safety professional, you need to really focus and drill into your people. So just remind them all the time. Early reporting, make sure that nothing bad happens to them when they do early report. Don't manage someone out of their business, because you'll never get an early report again. If you help that person, if you give them tools or techniques that they need to actually avoid an injury, then you're going to have everyone early reporting, because no one really wants to get injured, but they're a little bit scared of early reporting. So constant encouragement is key. Early reporting helps you identify the start of that wear out curve that I talked about. So if I draw that again, I'll draw that sort of here. Usually this is where the pain starts and this is where the injury happens. If you can get someone reporting here, that they're starting to feel something not quite right, or they're starting to struggle physically in their job, then you've got all this time to do something about it. That time is awesome. You can do something with that time. If you're getting the report at the pain stage, okay, suddenly you don't have as much time to stop the injury. If you're getting the report at the injury stage, you literally can't do anything because you've got the injury already. This is why early reporting helps fight against the wear out curve. Early reporting helps put in maintenance strategies for machines, and it helps put in maintenance strategies for people. It's key. The final thing we can do for prediction is sensors. So I personally believe that this will be the biggest step change in preventing injuries. So much so that I built a whole company around it. But sensors can predict things that humans can't even understand yet. Sensors are very powerful things. This will be the biggest step change, I believe, in reducing injuries. And why do I know that? Because it was the biggest step change in equipment reliability. As soon as we shifted away from looking at just historical data and trying to predict the future, and started getting sensors that would tell us when problems had started to develop, we were suddenly able to do a lot more and stop these machines from breaking. Same with people. So sensors can identify and trend problems well before a person can feel or understand them. They're collecting the data sets that I talked about before, so much more granular data sets, not just data sets that look at the injury, but data sets that look at what happens well before a pain or an injury even happens. And more granular data sets enable better predictions. And sensors don't just measure, they can actually, if you build feedback loops back to the worker, they can actually be used to engage the worker and give them valuable insights. So you can actually take them on the improvement journey or the maintenance journey with sensors as well, which is super valuable. You know, you're actually doing something with the data. You're giving it back to the person, you're helping them. But people are not machines. You know, as much as they can be similar, we've got some very key differences. What are they? It's difficult to replace a part or a component on a machine. You know, if they have a knee problem, it's very hard to replace the knee. I know it can be done, but it's definitely not what we want to do. And even when we replace these, you know, a component on a person or a knee on a person, that the person can never get back to normal. So it's not like a machine where if you replace an engine, you know, it's a brand new engine, it's awesome, the machine keeps working like normal. The second thing you can't do is really just change an old machine with an old person with a new one without a significant impact. So you lose their experience, you really impact that person. With machines, you can be brutal, there's no emotion. With people, there's a whole lot of emotion and experience involved. And the third thing is, probably relates to the third point as well, is you just can't program and operate a human in a particular way. We have free will, we want to do it our own way. We like using our free will. It's actually one of our advantages as well. So you can't just treat a human like a machine. But we have one advantage. Humans have an advantage. We have the ability to improve and repair ourselves. So when an engine starts failing, or when a wing starts failing on an airplane, it doesn't fix itself. You know, you need to do something. But if you have knee pain or back pain, there is actually something you can do. Your body will repair itself under the right conditions. So we have an advantage there that we try to tap into at Soter. People have the ability to improve and repair themselves. So a bit into what my company does. So we were built to bring reliability engineering techniques to people. We decided to focus on back and other musculoskeletal injuries. And the reason for that is back injuries specifically, and shoulder injuries as well, they're happening frequently. When they happen, they're super expensive. But they're actually predictable in a way that a back injury just doesn't happen like that. If you cut your finger, that does happen like that. That is a decision, or something has happened to the person very quickly. It's very hard to predict that. But on a back injury, you know, you start with using poor working techniques that develop over time, that start to cause wear and tear on the person. Then that person starts to get weaker. They start to change the way they move even more. They put even more stress on their back. Then the pain starts. You know, that might take a while. Then the injury actually happens. So it's a very long wear out curve. And you can put an intervention early on in this wear out curve. The second thing that we try to do in our company is we try to engage the worker. We realize that the worker has an advantage that they can repair or fix themselves. And we want to tap into that and help the worker in this way. So we have our product is called SoterSpine. It's actually a combination of a wearable device and a coaching program to change the way people move, to have them move in the right way to reduce, or in the best practice way, to reduce the wear and tear on their body and reduce the probability of them getting a back injury. So this is our little device. If you guys can see my camera, this is actually one of them here. So it's this small. This little device clips onto the back of the worker's shirt, and it's measuring all the movements they make. So every time they bend or twist or put a force on their body, our device is picking it up, it's quantifying it, and it's working out what sort of technique did that person use. If they used a poor technique, if they really moved something while twisting their back, or they maybe lifted something really heavy with a poor technique, the device is actually going to give them real-time feedback. So it's going to beep and vibrate and let them know that you've just done something with a less than ideal technique. That starts coaching the worker on what they shouldn't be doing. And what we see is just the device itself has the ability to change behavior, reduce hazardous movements, anywhere from 20% up to 70%. We've seen up to 90% as well in certain cases. So it really changes the way they move. A couple other things about the device. We've got a 30-day battery life. It's super light as well. So once you put it on, you don't actually feel it, and it's very unobtrusive to the person. The second part of the solution is the personalized training that we feed back to the worker. So we combine the wearable device with our mobile application. Here in the app, we tell the worker what types of movements they're making, and we give them feedback as well, or give them best practices of what they can apply to their job. So through our tutorials available in the app, we might explain to them how to lift, or how to avoid twisting, how to move your feet. It's advice that can help them change the way they move and stop. If they apply these new techniques or this new way of moving, they don't get the beeps and the vibrations from the device as well. So it's combining two elements to create this integrated coaching program for the worker. The final part of our solution is the analytics dashboard. So this is where a lot of data is coming back to the safety departments, to the managers, to the organization itself. So we have organizations where there's 1,200 of these devices distributed through the workforce. All that data is coming back to a centralized location. That is probably even more relevant in the times we're going through at the moment, COVID-19. What we've seen from many companies is they're not delivering training at all at the moment, because training typically was bringing people into a classroom and telling them how to move or how to avoid a back injury, which isn't that effective anyway, but that was the old way of training. And because of all these isolation rules, you can't have that many people in a location anymore. So a lot of training has paused in organizations. Our customers have an advantage because the training program is actually delivered with a device, and each worker manages their own progress through the program. So you don't sit in a classroom anymore with all your colleagues. You're actually getting all the data coming to yourself through the mobile application. You're getting the training through that. It's actually a way to distribute and deliver training in, well, it's always been our advantage, but it's an extra advantage for us now. All that data is able to come to a centralized location. So if I'm a safety manager, I'm able to sit in my office, I'm able to see who's progressing through the training. I'm able to see who has challenges, who needs an intervention, who's starting to, maybe have some problems. I'm able to group all that data together. I'm able to see within the workforce, which particular functions or activities or tasks are causing the risk. So gone are the days where I need to walk the floor of my 20 locations all across the US, right, to see where my risk is. I can actually sit in my office and all the data comes to me. And then it's granular data. So then I can build my predictive models and what I need to improve. On my second last slide. So we are available in two variants. So the first is the coaching program that I talked about, Soter Coach. It's the mobile application that takes the worker through a journey of improvement. The second is better for bigger locations. So this is called Clip and Go. So it's not reliant on the mobile application as much. A worker comes, they take a device from our charging hub here on the right-hand side. They scan it out using the integrated tablet, and they start getting the feedback they put it on and they start getting the feedback from the device. When they scan it back in, they get their data for the day. So we're giving them a little bit of coaching, but we're not giving them as much coaching as we do through our Soter Coach application. So how do we build reliability into engineering into a SoterSpine? What did we do? So we have the bathtub curve. So we've got specialized programs for new starters. We've got supermarkets in the States that just deliver our coaching to the new starter. It's really targeted and focused. All the app content has the ability to be personalized and customized for a customer. So we create specialized programs for them. And the second thing we've created is an early intervention program. So when you start to feel pain, our customers are giving this worker SoterSpine. They're going through our early intervention coaching program, and the goal is to change the way you move, reduce the stress on the body, and avoid the injury. So this is a really good use case to start using our technology. You don't need hundreds of devices or thousands like some of our customers have. You can start with a couple and start testing it on people who have pain and help them avoid the injury, help them avoid a back injury. When it comes to the Pareto rule, we're collecting big data sets. So that will fit into a Pareto rule, obviously. You can analyze the 20% of your tasks or activities or job roles that are causing 80% of the risk. Again, this data can be used for root cause analysis of 5 whys. So when an injury does unfortunately happen, you can look at a long data set of the person who got injured to figure out what happened to that person. And we're right in the predictive analytics space. So our sensor gives real-time analysis to the worker, which is really important. Also gives that data to the manager. And it's really granular data as well. So we're not measuring pain or injuries. We're measuring every single movement that the person makes that can then predict pain and injury. So it's real granular data. This is we've got now some longitudinal studies that have come in, and we're averaging a 55% reduction in manual handling injuries, which is really cool. And the final slide I have is this is our customer base. So you can see that we're in a lot of different verticals within industry. Obviously, logistics has a huge physical requirement that this sector does see a lot of back injuries. So this is where our bulk of our clients are. But we're in service and operations, we're in healthcare, manufacturing, and we're in construction, mining, and oil and gas. So we're quite diversified in the number of industries. And the way I describe that is people are all making the same movements. They're all making the same movements that cause the back injuries or the shoulder injuries. The reason they make the movements is different. So the reason you make a movement that might cause a back injury in logistics is very difficult to a healthcare. So to sum up this webinar, and I think we've still got some time for some questions, but to sum up this webinar, we've got a deal happening at the moment for all the attendees. So that if you do want to give our technology a go, come to this website on the bottom left. We've got a deal running for you guys. If you want to get in contact with me after this meeting, that's also great. So that's where I've got my information on the right-hand side. So if you want to take a screenshot or a photo of this slide and get in contact with us and let me know how we can help you guys.
Thanks, Matt. We have a couple questions here. One regards the device's ATEX capabilities. I assume that's your European code for what we have in the States called intrinsically safe. Do you want to discuss the device and ATEX and intrinsically safe environments?
Yeah, so we're halfway through the project at the moment to get our certification. It's a long and expensive process. We're looking at about $100,000 to get it finalized. We've got Chevron and hopefully BP, I think, potentially looking at helping us with that. So a couple of oil and gas companies. So, but we are not certified at the moment, which is a challenge in certain industries, I know, especially in chemical production. But I hope in 2020 we get our certification, probably towards late in the back half of the year.
Okay, great. Another one comes to us. Someone asked, how do you overcome privacy concerns of employees having to wear sensors?
Yeah, that's a really good question, actually. It's with our very first company, our customer, we faced that. So we've got a couple of strategies in place. Firstly, you have to overcome that gently, especially if there's unions or workers' councils involved. You've got to be gentle. But the first advantage we have is we're actually feeding all that data back to the worker. So each individual gets to see their own data. There's no hidden data from them. So they're able to log into their app and see exactly what types of movements they're making. We're giving them recommendations as well of what they should be doing. So that starts to break down the trust thing. So it's not just going to my manager in a black box and one day my manager is going to do something and I don't know what they're going to do. No, I get to see the data myself as a worker. The second control we have in place is if there is some pushback, we're able to anonymize the data back to the organization. So the worker still gets to see his or her own data, but the manager only sees anonymized or aggregated data. So if we turn that on, the manager has no ability to performance manage someone based on this data. There's just no way they can do it. So there's the second strategy we have in place. That's the two.
Great. A follow-up to the intrinsically safe ATEX was, what about the device being around just high voltage equipment in general for people that might work on a line, for example?
Yeah, we had one of our very first clients was actually a construction company that built high voltage power lines. They wore it all around these lines, and we found there was no impact from that. So with that, yeah, I guess the answer there is that no impact from high voltage. I can't be 100% sure there won't be. Well, here I'm talking like an engineer, so I'm putting a safety factor in. It might cause the odd wrong reading, but these will be filtered out over time. You know, like if I'm getting 100 readings a day and one of them is wrong, I think most of our workers can accept that. So, but we've never seen it happen. So I think the answer is that it has no impact.
Okay. The question is, have you gained feedback from users of the tool?
Can you say that again?
Have you gained feedback from users of the tool, either in talking with them or getting, polling them, about results, about their satisfaction levels? I assume.
Yep. So every single person that goes through our training program actually rates the program as they go through the application. So we've built it into the journey through the mobile application. One thing I should mention as well is when they're going through this training application, it's not something that they go through and wear the sensor for the rest of their working life. We usually limit it at a 10-day program. So we measure them halfway through the 10-day program and we measure them at the end of the 10-day program. The reason we do the 10-day program is after the 10 days, they've got all the learning, they've changed the way they behave, they've embedded these new behaviors, and that device actually goes to the next worker. So these devices actually cascade through the organization. But yeah, we're polling them at the midway and the end. We are 90% plus positive. It can depend on the organization, but I think the lowest positive rating we've ever seen is still above 75%, which is pretty cool.
And on a personal note, I've actually installed the device at multiple companies that I work with here in the States. So I have talked with workers on the front line that wear the device to get their feedback as well, because I wanted to make sure that we're putting out a product that was of quality and that they enjoyed as well, not just the employer. And one of the most interesting things I heard was people say, I've been doing this for 20 years the same way. I had no idea that was a high risk movement. And they really, truly did in that 2 weeks change the way that they did things for 20 years. I mean, it's the old adage of you can't teach a dog new tricks. Now, I won't lie. There were some guys that did, out there said, I've been doing it this way. I'm going to keep doing it this way. But there's a lot of people that realized they were at the, right side of that bathtub curve. And they truly did want to do his best so that they could pick up their grandkids and play with their grandkids, kind of thing with the aging workforce. So I saw it personally and just wanted to kind of mention that. I didn't have any data sets on it, but it was very interesting to see. Another question comes, that 55% reduction of soft tissue musculoskeletal disorders. What was the data set used for this?
Okay, so this was with one of our clients in the UK. So what we looked at a 4-year data set of, well, it's called slightly different in the UK, but it would be the equivalent of a recordable injury. So we looked at 4 years of data. So what this client had was 2016, 17, and 18. They had like almost exactly the same amount of injuries per year. And then we got into 2019 where they implemented SoterSpine and they rolled it out across their entire workforce, which was impressive. This was about 400 devices, I think, 350 devices rolled out across the UK. And so in 2019, their injury rate halved, specifically for back and shoulder injuries. So it wasn't the reason we did it over 4 years. It wasn't like they had a very bad year the year before and then they had a good year and it was bouncing around a lot. It was 3 years of absolute consistency and then a step change in 2019.
Another question comes in. Is this device just for backs or does it treat other body parts as well?
Yeah, for the moment, it's just for backs. So we're stopping back injuries. We are 2 months away from releasing our shoulder version of the product. So it's exactly the same sensor that you guys see here. We're also developing an armband, and this sensor is going to clip onto the armband here, and it's going to measure shoulder movements as well. So we developed the algorithms for the device itself with a hospital back in Australia. We now are able to measure the movements. We were able to deliver their staff coaching on these movements based on the actual device feedback. So we saw the same reduction actually. We saw about a 40%, I think, reduction in what we would deem hazardous movements for shoulders. And now we're just integrating that with the application so that we can deliver the same training experience for the shoulder. And then you'll be able to use the same device in back mode or shoulder mode. I think you're muted, Mike.
Yep, thanks for that. You would think in week 4 of conference calls or webinars, I would realize. We have someone asking, we have a lot of tough guys at our facilities. How do you get them to encourage them to self-report minor aches and pains?
Yeah, I mean, it's a great question. I worked with a lot of tough guys in mining, toughest of the tough, I would say. You've just got to keep trying. You've got to explain to them what's going to happen if they early report. So you've got to make them understand the journey from the early report. Put in some strategy on, okay, early report. If you do this, if it's back related, we're going to set you up with a SoterSpine early intervention device, or we're going to have you see our athletic trainer. This is what they're going to do. This is what our organization is going to do, and make them feel confident that you're not going to performance manage them out of the business, because this is one reason they won't self-report is they're tough. Second one is they're actually scared. So you've got to really drill the message of why they need to report to overcome the scaredness of it. And then when someone does finally self-report, make sure it works. Make sure your process works. Make sure they don't get an injury. Make sure they go back into the workforce and become your evangelist. And say, hey guys, like I would have never reported either, but I did. And this is what my organization did for me. And this is why you should report. If it's a higher risk one, because if you F it up, if someone in your organization is not aligned and something goes bad, no one will ever report again. So you need like the whole organization, you need managers on board, but you will get the benefit from it. It's a bit of work to get it up and going and get people comfortable, but you will get the benefit from it.
And I think that's a good point. At the companies that I've worked with the device, upper management might have the best intentions, but I think you did mention management, the supervisor, the mid-level management, that if you don't have their buy-in, it's going to be a hard sell when they don't even understand why this device is being used, and to be able to coach them, to coach the employee on the device usage. Sure. And the last question we had, does it apply to team lifts? I assume
I see that one. Yeah. And she just left, unfortunately. But so one thing I didn't talk about was we have an intensity model built into our algorithm. So we're actually able to detect if a lift is intense or not. And the reason it might be intense is because the object is heavy. Another reason is the person might be too weak. The third reason might be the person is fatigued. But all those reasons might result in the device measuring a lift as being intense. As soon as you do a team lift, you're going to halve that intensity. And because you've got 2 people there, you're probably going to do it with the right technique as well. So it will actually measure, it will help with the team lift. If you use the right technique, it's going to measure it as being hopefully low intense and you use the right technique.
Okay, fantastic. Well, we're right at our 1 hour mark. I want to thank everyone for attending today. We appreciate having you out. Matt, do you mind if we send out a link to the recording to everyone so they can have it, share it with their teammates? We thank you for coming today, for doing this for us. I have never seen this presentation you do before, so it was very eye-opening and awesome. We'd be glad to have you again doing different things in the future with the webinars and team rehabs.
Thanks for everyone's time as well.
All right, thanks everyone. Have a great day.
Cheers.